Hi everyone, I want to talk to you this morning about GFR glomerular filtration rate autoregulation. What does that mean? Autoregulation. Self-regulation, right? It's built in. So, what is glomerular filtration rate? The pressure inside the glomerular capillaries can increase or decrease, and that directly affects the glomerular filtration rate. Now, our blood pressure goes up and down throughout the day, doesn't it? Whether you're, it really depends on what you're doing at that time and what your needs are. Do we want glomerular filtration rate to change throughout the day? We don't. We want it to remain relatively constant, and it does. We have two different mechanisms: myogenic mechanism and the tubuloglomerular feedback mechanism. All right. So in myogenic, what does myo mean? Let's pull that word apart. Myo, muscle, genic, generating. So this is generated by the muscles. What muscles? Smooth muscles. The smooth muscles in the arterioles. Specifically here, we're going to talk about the afferent arteriole. Alright, so let's say there's an increase in blood pressure. What's that going to do? What's that going to do to the afferent arteriole? Is it going to cause it to stretch? Or it's going to more stretch or less stretch? You're going to have more, right? Because there's an increase in systemic blood pressure. And an increased stretch in the afferent arteriole, it means you're going to have an increase in glomerular filtration rate. You don't necessarily want that, though. So what happens is those smooth muscle cells will then constrict, and you'll have vasoconstriction of the afferent arteriole, which will lower the glomerular filtration rate back to normal. So increased blood pressure means increased glomerular filtration rate. We don't necessarily want that. So immediately, smooth muscles in the afferent arteriole will vasoconstrict and lower the glomerular filtration rate back to normal. Similarly, oppositely, actually, if there's a decrease in blood pressure, there's going to be less stretch. These smooth muscles are going to be relaxed. And what happens is less stretch means lower glomerular filtration rate. So you're going to have vasodilation of that afferent arteriole. If you have vasodilation, what's going to happen? More blood's getting into these capillaries, more pressure, and you're going to increase the glomerular filtration rate back to normal. All right, so decrease in blood pressure, decreased stretch, smooth muscle cells relax, vasodilation, increase glomerular filtration rate. Does that make sense? I'd write it out. I believe there's a guided notes question, but if you write it out a couple times, I think you'll be quite comfortable with this concept. All right, tubuloglomerular feedback. It sounds complex, but it's not that bad. All right, let's talk about some cell types first. All right, so we have the glomerulus, right? Remember the distal tubule, or some would call it the distal convoluted tubule? It comes right by the glomerulus, and we have those macula densa cells. And in your second to last page of the guided notes, I have this drawn out so you can see them and label them. And we also have the JG cells, or juxtaglomerular cells, which you can help remember this term. Tubuloglomerular, we have our juxtaglomerular, and those juxtaglomerulars are juxtaposed. They're right by the glomerulus. All right, and we're going to have signaling and talking between the macula densa and the juxtaglomerular cells. All right, so let's say we have an increase in glomerular filtration rate. What's that going to do to the filtrate? If we have an increase in filtration rate, well, we'll have more filtrate. If we have more filtrate, we're going to have more solids in that filtrate, so an increase in sodium and chloride. This increase in sodium is going to cause the macula densa cells to react and say, whoa, we have a lot of sodium here. We must have a really high glomerular filtration rate. So MD for the macula densa. They're going to release ATP, which is going to be converted and going to tell those the afferent arterioles to clamp down. You're going to have vasoconstriction of the afferent arteriole. I should say, sorry. It's going to talk to the smooth muscle cells around the afferent arteriole and tell them, hey, high GFR, let's clamp down on this. And they get vasoconstriction. All right? Now let's say it's high for quite a while, like quite a few minutes. GFR continues to be high. What's going to happen? These macula densa cells are going to signal to the JG cells, the juxtaglomerular cells, and they're going to say, hey, decrease that renin secretion. What will that do? That will lower angiotensin II, which will lower the RAS system, which the RAS system raises blood pressure. We'll talk about that in another video. All right? So prolonged GFR, increased GFR, means macula densa cells are going to sense that increase in sodium and chloride. They're going to signal to the JG cells, the juxtaglomerular cells, and say, hey, turn down that renin secretion. And the JG cells will respond. Now let's say these were both if GFR is too high. What if it's too low? What could we do? Well, if it's too low, there wouldn't be much filtrate, right? Low sodium and chloride then. Low sodium will cause the macula densa cells to signal to the juxtaglomerular cells, tell them, hey, we need more renin. Increase in renin secretion is going to increase angiotensin II and aldosterone and the thirst center. All right, does that make sense? So between these two, the myogenic mechanism and the tubuloglomerular feedback, it's hard to say, feedback mechanism, blood pressure is maintained at a pretty, I should say glomerular filtration rate, not blood pressure in the glomerulus, but glomerular filtration rate is maintained at a relatively constant level despite fluctuations in the blood pressure. All right, thanks everybody.